All right, let's try example 8.2.2. I'm asked to solve the differential problem. I'm given a differential equation here and some initial conditions there. All right, so I'm looking for a particular solution because I'm given an initial condition. So we're going to follow these steps just with a slight difference, slight change. If you notice here, my variable is t, not x. So everywhere where you see x, you would put t. All right, so let's see. F prime, we should replace it by dy over dt. And then f of t is y cubed t. All right. And then I'm going to separate the variable. I'm going to separate y and t. So I'm going to send dt to this side and keep t with it. On the other side, I'm going to get 1 over y cubed dy. And so this is what I have. I'm going to integrate both sides. So here I'm going to integrate y to the minus 3. On the other side, I'm going to integrate t. And I'm going to get y to the minus 2 over minus 2 equals t squared over 2. And I'm just going to put 1 plus c on this side. Since I'm given a value for f, some initial condition, I'm going to do step 4. I'm going to evaluate c right here. So if I look at this, so f2 equals 1, the variable is t, so t equals 2, and f is equal to y, so y equals 1. So I'm going to plug in y equals 1, and I'm going to plug in t equals 2, and I'm going to solve for c. So that means that minus a half equals 2 plus c, and so c is minus a half minus 2, so that's minus 5 halves. All right, and now we're ready for the final step. I'm going to isolate y, and so I have y to the minus 2 over minus 2 equals t squared over 2, and we said c was minus 5 halves. And now I isolate y. All right, I'm going to multiply by 2. This is 1 over y squared. Actually, let me multiply by minus 2. So I'm going to get minus t squared plus 5. To get y on top, I'm going to put 1 over. So 1 over 1 over y squared. That's going to give me y squared. And so I need to do the same on the other side. So minus t squared plus 5. And so y squared is 1. I like to write it in that way better just because it's one fewer symbols, but both are fine. And now I need to get rid of y. So y would be, get rid of the square. So y would be plus or minus square root of 1 over 5 minus t squared. Now I'm asking you for the solution, and here I have two different solutions. I have the positive root or the negative root. I need to pick which one. Since I have that y equals 1 at t equals 2, I need y to be positive, and so that means that y is positive 1 over 5 minus t squared. And so final thing, answer the question. I need to solve for f, not y. And so the final answer is that f of t is square root of 1 over 5 minus t squared. All right. Let me do the other one, the next problem as well, just to show you the difference. In the problem we just did, we were given initial condition. We were told that f of 2 is equal to 1. So when you're given this, you're looking for a particular solution. You're looking for a specific function. In the next problem, in example 8.2.3, I'm asked to solve for f of x, and f prime equals e to the x minus f of x. I'm not given any initial condition, so I'm looking for a general solution. So there'll be a constant somewhere in the answer. All right, but otherwise, steps are the same. I'm going to start by replacing f prime by dy over dx, and that's going to be e to the x minus y. This doesn't look separable because the x and the y are in the exponent, but I can use rules of exponent to rewrite this as e to the x over e to the y, and so this proves that it's a separable differential equation. Now I'm going to separate the variables, so I'll get e to the y dy equals e to the x dx. I'm going to integrate both sides. And so I'm going to get that e to the y equals e to the x plus c. Step 4, no initial condition given. And so I don't have to do anything. And in step 5, I have to solve for y. So e to the y equals e to the x plus c. I'm going to apply log to both sides since that's the inverse function of the exponential. Again, notice that when I apply log to that side, I have a single log with everything inside. Right? And so I get that y is log of e to the x plus c. All right, so this says that we should solve for f of x, and so the final answer is f of x equals ln of e to the x plus c. For every value of c possible, this is a solution to this differential equation. What we have the general solution.